record on this computer. Right, okay. Boom, let's do this. Okay, home. Okay, in case you didn't get the announcement, okay, let me move the chat to the other window so I can see it. Yeah. I do try to make sure that my my wallpapers are aesthetically pleasing. So first off, new tab here, lecture recordings. Click on it. It's a playlist of all the stuff that we've recorded, and it turns out that Zoom actually will, if I'm recording via Zoom, Zoom will censor your name. So that's cool. You know, so if you'll notice, your picture and videos might be over here, but none of our names are, which is okay. That's cool. Next, so that's that. Let's go ahead and open up our Runestone textbook. Fall 2020 Rosen, right? I've done this a couple times as well as played with it. So let's go look at our assignments. Click on the assignments tab. So I added these, by the way. These are just for our in-person exercises. Don't worry about that. They're, again, I will tell you whether or not something's worth panicking over. These are not worth panicking over. So readings, which were due yesterday, but if you didn't do it, that's fine. So most of these deadlines are soft. I'm gonna be running the grader for the first 2 weeks at the end of this week, so no worries. So these readings tell you what I care about. Notice that they say, like, it's not yet graded, 1 point minimum activities. If I hit score me, it will say, let's see what it changes to. It tells you how many points you would get. This one is saying I got 0 out of 1 points, minimum 2 activities required, because it wants me to run those 2 activities here. So you've attempted 2 out of 3 activities on this page. So basically it's just a way of saying, did you actually, you know, do this stuff? So yeah, I think you do have to do the activities on the page, but I mean, they're not too bad. They're good examples. You can play with them also, which is part of the reason why I like this textbook. These are less graded so much as check your understanding. Notice that I'm going to just pick some ones at random. It still counts them as completed. That's okay, because these are those kind of like interstitial. I'm not sure what the word is. Basically, they're the kind of questions that appear in the margins a lot of the time. Check your understanding in a typical textbook, right? So what I care about is like first exposure over here and running stuff. The videos that I created are basically there as either supplements or as replacement, depending on whether you're not which you prefer. Some of you might prefer the examples that I give you there. But you'll also, but again, there's not necessarily a one-to-one mapping in the background. 1 second. Yes, that is Happy Feet in the background downstairs. There is not a one-to-one mapping for every video, because like in my videos where I talk about values and data types and operators and operands, when I talk about operators and operands, I went ahead and talked about order of operations as well. Now, Meet Patel asks, is the quiz going to be like the questions on Runestone? Yes. Yeah, my idea here is that you're on your quiz, you will write code, and then I will have a auto grader, a unit tester. For those of it's an auto grader, but for those of you who know what a unit test is, it'll run unit tests on your code. Perfectly fine, Derek. Be sure to sign in for attendance. And basically, my objective is auto grading, and not only auto grading, but seeing whether or not you can see how many tests you were able to pass. Okay, so now for the exercises all come from this from 2.17 and 2.18, right? So the exercise section is not meant for you to go through and work on all the sections, right? Have you ever had have you ever had a reasonable professor basically say, do all the exercises at the end of chapter 5 or something like that? Like, no, in mathematics, typically your professor says, do these problems, you know, do these problems out of the textbook. And that's pretty much what I'm doing over here. I'm just saying, these are the specific problems I want you to do out of the textbook. I'm perfectly able to make some of these. And in fact, if you're having issues with them, let me know. I recently actually just removed one from the homework because the auto grader was having issues. So if you have any issues, let me know. The later we get into the book where we're actually writing methods, the better the auto grader will be, because there's only limited things we can do with the auto grader at the moment. Okay, but the quiz will be pretty much. I would say that the quiz difficulty would be. Let's go over here. Something like this question over here, the compound interest question, or this one where basically you convert, but that was there. The dog is downstairs. Happy Feet, can you come upstairs? Maybe she'll probably make her way up earlier. Quiz is not in class. Quiz is take at your own leisure. I will post it. You'll be able to access it from the overview. I'll make an announcement and link you in the announcement. The quiz will have essentially, so basically the way it will work is I'll make a due date and I'll give you a time limit. So when you actually start it, you'll have this amount of time to complete it. And then I will, and if you turn it in late, I will use the formula I've established to basically say what the penalty is. And remember, it's 0.1% per minute. So 10 minutes, if it takes you 10 minutes longer, then it's just a single percentage off. So it's very reasonable, right? If you take an hour longer for some reason, it's 6% off. If you get interrupted, say, because there's a massive storm passing through and you lose power, let me know and I will accommodate, okay? The entire thing is just be reasonable. Okay, so yeah. Now the quiz is primarily, I want to emphasize modular arithmetic because that is an issue that I find students have. Modular arithmetic is important. So be sure to just learn how to do it. All right, so I want to go ahead and now talk about the biggest kind of pitfall, the first pitfall I see students fall into. Okay, so let's go ahead and everybody should be able to see my idle over here. All right, so I go over this in my videos as well, but the biggest pitfall is what we see with reassignment. Now, first off, if you're coming from a separate programming language, 1 second. Happy Feet, you don't want to come upstairs? Annie, can you take care of Happy? I think she's asking to go out, and my wife is not there. Sorry. All right. So if you're coming from another programming language, when you create variables, you might be expecting to do this, like int x is equal to 5. And if I mistype stuff, I've got a new keyboard, so just bear with me. But in Python, this is what we are working in what we call a weakly typed language, meaning that basically we can write this statement over here just fine by itself. Now this statement for everybody, yes, I did get the ergonomic one. This statement is 5. It basically says we are going to assign the value 5 to x. Now, it's easier if you mentally think of the equal sign in programming more like this, where we have an arrow. But of course, you would read that as x is less than -5, which doesn't really make sense. So some programming languages have what we call the walrus symbol instead, but that requires more keystrokes and programmers are lazy, so we just use the equal sign to do what we call assignment. And basically that says we make a box called x and we store the value 5 in it. Similarly, we can store basically anything we want in a variable. Okay? And that just basically means that, and again, this means that we're taking hello and storing something in it. Now, the biggest thing, and this is also going to be one of the things I do on the quiz, is making sure that you're developing the appropriate mental model, which is that this assignment operator is, again, takes what's on the right side, evaluates it, and puts it in the variable on the left. So if I say answer is equal to x times 2, right? It's going to evaluate this expression. 5, x is 5, so we replace x with 5, multiply it by 2, and store 10. Nothing too scary about that, right? If I print our answer, don't have to do prints in the REPL though, we see that answer contains the value 10. Nothing too scary there. So now if I do x is equal to x times 2, that's kind of weird looking, right? If it was f of x is equal to x times 2, you'd expect that in mathematics, but that's not what anywhere near what I'm saying. I'm saying x is equal to x times 2. Now, again, this is not the equality sign. We are not creating a strong binding between the value x and 5. We are storing a value in the variable x. We are storing this value, x times 2, in the variable x. So what is x times 2? It's 10, and we're going to store that in x. So that will overwrite the value that's inside of x. So somebody's saying, don't we need to do int x to make it a number, not a string? It's only a string if I put parentheses in it or take it through the input function. So I put quotation marks around it or put it in the input function. So these right now, what I'm working with now are called int literals, which are literally integers. So here, again, if I do y is equal to, so that's the first pitfall, right? That you can actually do this. So currently x is 10. Let's do x is equal to x plus 1. This is a very common operation where we're counting up, using a single variable to count up. And that just simply increments x by 1. It takes 10, adds 1 to it, and stores it in x, which gives us 11. So here's the big pitfall. When I say y is equal to x, okay, I did y is equal to x, and then I say x is equal to, so first off, x is equal to 11, y is equal to 11. Now if I do x is equal to, x is equal to x plus, whoa, that is not at all what I wanted to do. Magnifier. All right, x is equal to x plus 1. So I'm going to execute, x is currently 11. We said y is equal to x. So we stored 11 in y, and now I do x is equal to x plus 1. The question of the day is, and one of the big questions that will be on your quiz is, what is the value of x and what is the value of y? Any takers? You can go ahead and unmute yourself. Right. A lot of people are putting in chat, x is equal to 12 and y is equal to 11, which is completely and utterly correct. So now this is because in mathematics, again, this is not necessarily this is not the equal sign in computer science. This is the assignment operator. We take what's on the right and store it in the left. We are not creating a hard thaumaturgic binding between x and y. We are just simply saying, copy the value that's in x, store it in y, please. Okay, so when we increase x by 1, y doesn't increase by 1 because they don't have a hard binding between them. They are separate and independent variables, right? We are taking one value and storing in another. Because think of the alternative. If we did create a hard binding between them, so that when one value went up, the other value went up, that'd be a lot to remember when you were programming. That would be terrible. So every variable is its own kind of thing. It's its own box with where you put in a value and you can retrieve the value. So any questions on this? This will be one of the questions that I know I want to do on your quiz or something along this line. And I also want to know that, and I also know that I want to do something with modular arithmetic. So if I'm just spitballing here, here's what I'm probably envisioning. You're probably going to have 4 problems. One of which is basically this conceptual kind of thing. Sarah, I'll get to your question in a second. So one of these kind of things where basically I'm asking you what the values are. Another one I'll probably ask you is a parse and puzzle, where, so those are the ones where you drag and drop the code into the appropriate spaces. I'll probably give you a harder question for that because the code will be there. It's just for you to figure out which line goes in which order. Okay. Then probably something to do simple with modular arithmetic, and probably then something else to do with modular arithmetic that's a parse and puzzle. So, because again, I like modular arithmetic. Now, that's probably the way it's going to go. I might decide to go instead do something a bit easier. If this was a normal class where you'd be taking an exam on paper, I am a fan of problems that look something like this, though. So all right, do this in your head on an exam without a calculator. Not 0, not 0. It is 1, 2, 3, 4, 5, 6. It's actually not that hard, right? So the trick is modular arithmetic over here, right? We are dividing this number by 2, right? We're dividing this number by 2, and I love seeing the O in the chat. It makes me feel like I'm doing my job because it just clicked for somebody. Right? So when we divide by something by 2, it's going to have one of 2 remainders, a 0 or a 1, right? 0 if the number is even, because that means that it can divide by 2 cleanly, or if it's an odd number and you divide it, it's going to have a remainder of 1. So this just simply simplifies to 1, and 1 times anything is the thingy. So in a similar vein, I also love doing something like this. On paper exams, I love doing something like this, where I have a small number divide a really, really big number. Now, what's the answer for this one? 0, because I'm doing integer division here, right? This is integer division. So some small number, divide some big number times anything else. Well, this doesn't really matter. I can make whatever's after this division kind of thing as complicated as I want it, because anything times 0 is 0. Math is super easy. It's like those physics or chem exams that you take. The professors put in a lot of work to make sure the answers are 0, 1/2, or 1, because those are easy to check. So those are the kinds. Now, but this actually leads me to an interesting thing that I want to mention if you're coming from another programming language. And if you're not coming from another programming language, this is just interesting info to know. In programming languages like C and Java, there's a limit to the size of an integer, right? Which is around 2 billion, just because that's how big we can store a 32-bit number with positive and negative signs. But Python does not really care how big your numbers are. That's one of the wonderful things about Python and it being this weakly type system. So I'm just going to do, now this one I won't ask you to do in your head because that's patently absurd. Right? But notice I've just got these really long big numbers and I've got a plus operator and I've got another big number. And Python just goes, okay, no problem. It adds them up perfectly fine. It does not care how big your numbers are. So so that is something to just keep in mind. It really doesn't, you can have as big of a number as you want. Now with doubles, on the other hand, or floating point numbers, let's see what happens. Point times, and again, I'm just jamming on the keyboard here. You'll get scientific notation at some point. This is the way because, so with integers, that's pretty easy, you just make them bigger. With floating point numbers, they follow something that called IEEE floating point notation, IEEE 754. Now this is completely, now this is the kind of stuff where basically people say, oh, I don't, you know, what am I, when they say, I could learn computer science on your own, this is the kind of stuff that's useful to know about, that you might not get from learning on your own, which is that, so IEEE is a big organization. Again, they wrote basically these formulas, which you'll learn in later classes when, that basically specifies how to store these numbers, how to store these floating point numbers. And so here's a 32-bit floating point number. Let's go to the 64-bit, where it basically says we use 1 bit for the sign, 11 bits for the scientific scientific notation exponent, and then here's for the fraction. So you don't have to know this. It does mean there is a minimum, there is a big smallest value and a biggest value for this, which is that it can go up to 2 to the 1023rd power, essentially. So there is a kind of limit for floating point numbers, although I doubt you'll hit it. Just worthwhile to know. Am I going to test you on that? Oh, no. That would be silly. All right. So anyway, I just wanted to go over those common pitfalls. Why is there a limit in Java integers but not in Python? Because Java is strongly typed. Java is strongly typed, so with integers, let's see, 32-bit. Basically, you've got integers stored in what are called 32-bit integers, which are in this range. So basically, when you create an int in Java, it is from the range of -2 billion to 2 billion, because that's the most you can store in 32 bits. If you want something bigger, you use a long, which is 64 bits. So in Java, you'll see for 64 bits, you use a long. And Java doesn't have anything bigger than 64 bits. If you need bigger numbers, then use a special class called big integer, or the big int class. So, and this is because Python doesn't think you care, doesn't really, will assume, and it's just because of basic different assumptions that were built in when the programming language was written. Python assumes you don't care how much memory you're using to store numbers. Java assumes you do. It's just different objectives. Okay. So today today's activity. So any questions about this before I go on to today's activity? And this is typically the way Tuesdays I think will work, which is that I will review stuff for about a half an hour and then we'll go on to a shorter activity. Right? This isn't enough where basically if you come to the lectures, you're going to learn everything, because that's not the point. The point is to do a lot of activity, to get these activities done that normally would be a homework. So, but today we're going to do something fun and creative. So if you'll notice, I put up here week 2, part 1. You don't need to click on assignments. It will just be there. What you'll want to do is click on, let me turn off Discord. You'll want to go to sign into Runestone and click on project 2, driving the turtle. It says skill required, turtle graphics basics. But don't worry, it teaches you the basics in the first bit. So we're going to talk about turtle programming. I'm going to give everybody a minute to log into this, and it's actually going to be quite fun. Now, I'll show you how to do. Now, you'll be able to do this in idle if you prefer, but you can do it here as well. And it may be easier for you to do it on this page. So click on driving the turtle, and there. Okay, so see, fortunately it links to Wikipedia so that I can talk a bit about what turtle graphics are. This is going to be quite the freeform lecture. And just in case you're curious, we will be doing the third project, which is a bit more mathematically, not intensive, but focused. It's not intensive because we're going to make the computers do all the hard parts. But this one's pretty fun. So all you have to know is about basic Cartesian planes, which is that if you've graduated high school, you've learned that, even though it sounds way more harder. Basically, you just got to know how to do 2D stuff. So remember, a Cartesian plane is this thingy, right? So turtle graphics were created for the Logo programming language, which was designed to teach programming. Part of it was used, so they initially intended it for children, but the Logo programming language was just so awesome that it eventually became used for other programming languages, especially for simulation. So you can do a lot of simulations in logo-based programming languages because of their paradigm of using action, actors on a stage and performing actions. But this is the way basically turtle graphics work. Imagine you've got a little turtle living on a 2D plane. So let's go ahead and, you know what? I will show you by doing this in idle first, and then we can run their example. So if you're running this in idle, by the way, the first thing you'll need to do is import the turtle library, which says to Python, hey, you've got like 1.5 million libraries that I can't keep in memory. Let's load just one of them up, called the turtle library. Import turtle. So you should be able to do that in idle if you want to follow along, or you can do it in the text box over here. Your browser will support this. So we import turtle, and now I'm going to create a new turtle. I'm going to give him a name, Bob. Why Bob? Because it's short, has 3 letters, and if we give names to stuff in computer science, we often use Alice and Bob. C will typically be Carol, and the other most common name we use is Mallory for malicious Mallory. Who's typically the code breaker or the criminal in security exercises. So Bob, so now we're going to just say a magic command. Bob is equal to turtle, whoops, again, new keyboard, turtle. I'll learn how to type one of these days. Okay, and you'll notice that a nice window comes up over here, which is really nice, which is a really nice feature if you're programming in idle, that you wouldn't get necessarily in other programming languages, because we can do this line at a time. So why do I need .turtle? So turtle is the package, and I'll explain this. It gets explained more in module 4. Just remember, this is magic. Phrase right now. I don't like doing magic phrase, but you'll understand it in about a week or so. But what's going on here is that we're saying, look inside the turtle package and run the turtle constructor, this capital T thing, which says, make me a new turtle object. So, and then we're going to store him in a variable called Bob. So Bob is now a turtle. So this is our turtle. He doesn't look very turtley. I'm going to change that. Bob dot, I think, set shape. Let's see. You know, there's a lot of stuff over here, so give me 1 second. Turtle. Python. And I know you can't see it. API. So I can load up basically the library from the turtle library from here to figure out what to do. Let's see. There's 1 million commands. Well, not really, but let's see. Shape. So, turtle dot shape. Is it set shape? Sorry. Appearance. Yeah, shape. Okay, so it's turtle dot shape. So yeah, let's make him look more like a turtle by giving Bob the shape command. Shape, and I'm gonna call, and there's a bunch of pre-made shapes in there that you can use. I'm gonna just use the turtle shape to make Bob look more like a turtle. And so now rather than that, we've got a little turtle over here. So how far will it move? I will tell you in just a second what the units are. So this is our Bob turtle. This is a unmarked coordinate plane. This means that basically that you've got, that he is at location 0, 0, right? So he is at 0, 0, and he's currently facing this way, the positive X direction, right? So, and he's actually very simple to move around. To make him move, you do Bob dot forward, and then you tell him a distance in pixels. Now, a pixel is a small little square on your computer, right? Specifically your computer monitor. I want to make sure I get it right. So pixel is picture element. If you zoom into an image, right, it's these tiny little squares that are on your computer. This is what your typical LCD laptop looks like. A pixel is typically made up of these little sub-pixels of red, green, and blue, and they're and at a certain intensity, you interpret it as a solid color. So, so if you just lean into your computer and look, you'll notice that your image is made up of tiny, tiny little squares. If you are running one of those wonderful Mac Retinas, Macs with the Retina, you may have some difficulty seeing that because those are very high resolution screens for a very small screen. So, so anyway, this will move him forward 100 pixels. So now the paradigm for drawing with a turtle is fairly simple. The turtle is dragging along a little pen. And this giant Cartesian plane that he's walking on is a canvas of paper. So as he moves, he drags that pen along and draws. We can also tell him to turn in directions. Bob dot right, and that will turn him a certain number of degrees, right? Not radians, degrees. So we tell him to turn right by 90 degrees. He does so. You typed forward wrong. You're missing an R. So don't worry, it's very common. I've done that more times than I'd like to admit. We can also shorten forward to just FD, by the way. That's just shortened. But now we can see we've drawn that. And what's amazing about this is that you can do a lot of things with this to draw very, very complex shapes. So, and that's what essentially you're going to be doing today. So if we go back to the driving the turtle, let's go ahead and run this or take a look at this. So turtle, import turtle, my turtle is great. So we create a turtle here. So you can use the color command to set the turtle and the pen color to be green. So this draws a green line 50 pixels. And now look, you've got up. So this lifts the turtle's tail up, which is what's got the pen on it. Then it tells him to move forward 50. And because the pen is up, it's not drawing. Then tell him to turn, put his pen down, and move backwards. So if we run this, we see that he moved forward, turned right. So he moved forward, lifted his pen up, moved forward some more, turned right, put his pen down, and moved backwards. If I tell him to move, say, turn right 45 over here, save and run, he does so. Now, your objective for the day is actually fairly simple. You've got a couple of basic instructions: forward, back, left, right, up, down, color. You can look more of them up by simply Googling Python turtle and then clicking on basically the first link. Make sure you've got Python, some version of Python 3 selected over here. The current version of Python is 3.8. Any of the threes will work, just not 2.7. That's old. And you can look up all the commands if you want to. We will get into more, we will have an entire module based on the turtle, and we use it to learn how to run for loops and stuff. What is a for loop? Well, I'm going to teach you this, which is the second pitfall that we have. Don't worry about it. It's not part of this chapter. It's just simply something, a tool I'm giving you to make your job slightly easier today. Okay, which is the for loop. Now, a lot of this would be basic. Notice that basically if I wanted to do a lot of stuff, like if I wanted to repeat this a bunch of times, I would have to do some annoying amount of copy pasting. Right, so here I want to do it 3 times, and it does that it's actually pretty interesting how that worked out. But I had to copy paste it 3 times, which is kind of annoying. I could make it a function, but I want to introduce the for loop. So what is a for loop? A for loop is basically, there are 2 types of loops in Python. What is a loop? A loop is when we want to, is a tool we use when we want to repeat something. In all programming languages, not just Python, we have 2 types of loops. We have definite loops and indefinite loops. Definite loops are for when you definitely know how many times you want it to loop. Indefinite loops are when you when you definitely don't have any idea how long you want it to run. We'll learn more examples of what those are, but right now I'm going to teach you Python's definite loop, which is the for in range loop, which is, again, it's going to be a magic word, but it's fairly easy to start. It's called the for loop because it starts with for. For I, honestly, you could put anything there, but I like using I. You could put an underscore, but I'm going to just do I because that's the way you'll typically see it. For I in range, and then you just simply put inside range how many times you want it to loop. So, and then now this is how for loops work in Python, which is that everything you want to run inside of the loop, you indent it using tab. So there I just simply selected everything using shift, holding shift, and using the arrow keys to select it all, and then hitting tab to indent it. And so that tells it, because it's indented, everything is inside the for loop. So, again, for those of you who have never seen a for loop before, this is a magic phrase that says, this will run the following code 3 times. This, if I change it to 10, it will run the code 10 times. 4, 5, 6, 7, 8, 9, 10. You'd think it's less powerful, but this is just simply one way we can do the for loop. It's actually quite powerful, but I just wanted to show you the simplest way to do it so that if you want to draw a square, you don't necessarily have to do that. Now, I will point out there is a 30-second time limit, I believe, that Python does, which is that basically that if your program takes 30 seconds to run, more than 30 seconds to run, it will terminate. So just keep that in mind. But with that, your objective for the day in the half an hour you have left, have fun. Basically create an interesting picture. Draw something that's fun and intriguing. And that's your job for the day. So submit some code and then answer the following questions about whether you were comfortable, learning, or panic. By the way, we'd like you to be in learning or comfort. how long the project took, and the things are. We'll be doing a lot more of these turtles because they are extremely powerful tools for teaching. You could just do it in idle and copy paste it over. Now, if you don't do this, now for those of you, again, who don't want to do this in here and are not going to do it in idle, the only thing I want to warn you is that idle is awesome because it doesn't automatically close. It's waiting for more commands. So if you're not running in idle, if you don't want your turtle window to immediately close, you'll need the magic word or this magic phrase, turtle.done, which will keep it from closing if you're using, and you only need to do that if you're like working in PyCharm or Visual Studio Code or something like that. Is this due at end of class? Ideally. You'll pretty much get graded for just putting something, automatically graded for putting something in there and answering the questions. So again, this is more of a have fun, try to do something interesting. You use your curiosity to explore. If you can't get it done by the end of class, let's see when I have it due. Yeah, much later than I thought I did. Okay, so yeah, you've got plenty of time. There's no need to demo it. So I'm going to separate you all out into breakout rooms, and then I'm going to wait and go through and see how people are, what fun people are having. Okay, and when you're done, you can leave. All right, so I'm going to stop sharing, and I'm going to split you up into breakout rooms. Any questions before? Any more questions before I split you up? I see your message, Mark. That is something that will probably take me some time. So that is something I could do after class. You could look it up online, but it's more exciting if you explore and do something on your own. Can I show the 4 iron range thing one more time? Sure, I'll do that. I'm gonna go ahead and set up the breakout rooms, but I will do that. What does the turtle.done do again? You can demo to me after the class. I want to help students during the lecture. That's my priority for lectures. Oh, and that does remind me. So I think what I'll do is that for the lab sections, just simply because of the way the breakout rooms work, I'll come to both the lectures. I'll be there. If the breakout rooms are set up, oh well. After that, I will set up my own Zoom room so that you could come by and demo to me during the labs, so that if your TA isn't getting to you or there's a lot of questions that are going on, I can do that. I understand that you have to leave, okay? You can make multiple loops if you want. The loops are not a necessary part of this assignment. So let me go ahead and start the breakout rooms, and then I'll just quickly show the for loop again to people who want to see it. So create room, open all rooms, and share screen again. So many things on my window. Screen 1, driving the turtle. 4i in range is how you do a loop. 4i in range, and you just simply put the number inside range that you want for how many times you want to repeat. And then for things to go inside the loop, you just indent everything inside of it. Once you're done with the loop, you can just continue outside of it. If you're working in idle or the textbook, you don't have to worry about turtle.done. Okay, and let's see if okay. All right. Any other questions? Let's see. Stop sharing. There it is. All right, your breakout rooms are open, so go ahead and jump in them. I will be by momentarily. Hello?
Hi.
Hello.
Hi.
So, how does this feel? Yes, no?
Weird.
Kind of cool. I like the turtle.
Mm-hmm. Yeah.
I'm just playing around with it right
That's
now.
what you want. That's what your objective is. I just want you to play around and basically learn by exploring. It sounds kindergarten-y, but it's a good way to learn.
Yeah, no, I love it. Yeah.
All right. Is anybody having trouble getting it set up, though?
I was trying to make a file and then run it in idle, and for some reason it wasn't working, but I don't know if it's just my computer.
Go ahead and share your screen and I'll take a look at it.
Here, let me bring it back up again because I closed it.
Sorry, I was smelling like spray paint or something, and I think that my window was open, so I think somebody's spray painting.
Okay, here we go.